here's a bit of a weird example, but we're going to use some electric field stuff to find a pendulum in, or find the period of a pendulum in an electric field. Alright, so this, I guess there's electric fields everywhere. So let's try and find the time it takes to, um, for this pendulum to swing back and forth one full rotation. So let's kind of look at how we would do a normal pendulum, right? The idea of a normal pendulum is the time it takes is 1 over. So the electric, or so it's going, the time it takes is 1 over the frequency. And so that is equal to 2 pi times the square root of L times G. And so we don't really need this frequency. We could solve for it later, but we want to find this unknown T, and we have L, and we can solve for G in terms of this. So if we use our favorite equation over here, we're going to rewrite this in terms of what we have over here. So we have our favorite F equals ma. F equals ma. So the sum of forces is equal to the mass times the acceleration. So we're going to set two forces equal to each other and solve. So we have Fg is equal to m times g, because this is just the force of gravity. And so we're going to set this equal to this Coulomb force over here. And so the force of a Coulomb is QE. That looks like a G. Q times the electric field. And so now to solve for G, because we have G over here and we just want to substitute back into our equation in terms of G. So G is just going to be QE divided by M. QE over M. So now we can substitute everything back into this equation. So the time it takes is going to be equal to 2 pi times the square root. Let's open a big square root over here. And then we're going to say the length of the pendulum, which is 0.5. 0.5 meters. And then we're going to do, let's rewrite this just so in terms of the other ones. So this is going to be square root of L times QE. Well, it's over G, so QE is actually going to be on the bottom. So Q times E, and then multiplied by M. So now we can properly substitute our variables into this equation. And so now M is just 1 gram, which is 0.001 kilograms, because we need to have everything in SI units. Alright, and then Q, what was Q? Q is 2 microcoulombs, or millicoulombs. So we're going to say 0.002 coulombs times the electric field. And so that's going to be 1 times 1, 2, 3, 4, 5. 1 times 10 to the 5. 10 to the 5 newtons per coulomb, which is, if we substitute all of this into a calculator, the time it takes is 9.9 times 10 to the negative 3 seconds. And that is the answer.